Hi, in this video we are reviewing the keywords for the counting rules. We begin with the fundamental counting rule. It's used when computing the total number of possibilities for a sequence of events. Keywords, repetitions, digits, letters, etc. Our example states the following. George is buying a car. He has a choice of 5 models, 6 colors, and the vehicle can be gas powered, electric powered, or a hybrid. How many car options are possible? Well, we have 5 different models times 6 different colors times 3 ways of powering the vehicle. We multiply all those options together, and that's going to give us 90. So there are 90 different options for George to choose from. Permutation rule number 1. The number of arrangements of n distinct objects is n factorial. The factorial just means to multiply all the whole numbers from n all the way down to 1. Keywords: arranging, order. We're using all the objects that are given to us. So here's our example. A group of 8 people race in a track and field event. How many ways can the group finish the race in order? The answer is 8 factorial. 40,320 different ways. Permutation rule number 2. It's the number of arrangements of objects with some of the objects repeating. Our formula is this. It's n factorial, so the total number of objects factorial, divided by the number of repetitions for the first object factorial times the number of repetitions for the second object factorial, and so on. Some keywords are identical or you visually see repetitions. Here's our example. How many permutations are possible for letters of the word Alabama? So here we can visually see that A has 4 repetitions. All the other letters repeat once. So there's a total number of 7 letters, so 7 factorial, divided by 4 factorial, that's the number of times A repeats, times 1 factorial for all the other letters. 7 factorial is 5,040, 4 factorial is 24, 1 factorial is 1. We divide 5,040 by 24 to get 210. Permutation rule number 3. The total number of permutations for R objects selected without replacement from a group of n objects is, it's n choose R permutations, n factorial divided by n minus R factorial. Let's see, so it says 3 people are chosen from a group of 55 to win 3 unique prizes. It should say here, let me clean this up, how many ways can this be done? So for this type of example, we're choosing 3 of the 55 objects and looking at the total number of permutations of 3 selected objects. So the answer is 55, choose 3, which is 157,410 different ways. The combination rule. So remember, combination order is not important. We're just counting the total number of groups. So the total number of combinations of R objects selected without replacement from a group of n objects is, and here's the formula, n choose R combinations, n factorial divided by n minus R factorial times R factorial. Keywords, order is not important. We're counting the number of groups or committees. Selection without order. It says a group of 40 people wish to select a committee of 5 to review a contract. So remember, committee's a group. Order doesn't matter. How many committees are possible? 40 C5, 658,008. And that concludes our review of all the key words for the counting rules. Thanks for watching the video.